Hi, I'm Rayhan,
Hi, I'm Ilyas.
and today we'll be teaching a lesson on the 12 basic functions. The objective of this lesson is to be able to recognize the graphs of the 12 basic functions and determine the key terms used to describe them.
Let's review some of the terms used to describe functions. Domain. The set of values from which the input values, x values, are taken.
Continuous. Every point in the domain of the function has a value. There are three types of discontinuity. The first is removable discontinuity. This is where x is equal to c is not defined. An example would look like this. Infinite discontinuity occurs when as x approaches c from the left or right, it is equal to negative or positive infinity. Jump discontinuity is where one two-sided limit does not exist, but two one-sided limits do exist but are different values. An example looks like this. Those are the types of discontinuity. Now we're going to go back to the key terms.
Bounded. The function's graph lies entirely between two horizontal lines. Note, a graph can be bounded above or below or completely bounded.
Even. The function's graph is symmetric about the y-axis.
Odd. The function's graph is symmetric about the origin.
Increasing. The function's graph is headed upward as it moves from left to right.
Decreasing. The function's graph is headed downward as it moves from left to right.
The first function we'll be looking at is the identity function. The equation for this function is f of x is equal to x. It looks like this. The domain, as you can see, is from negative infinity to infinity, and so is the range. The y-intercept is 0, 0, also known as the origin. It is increasing on the interval from negative infinity to infinity. It is never decreasing and has no relative maximum. It is continuous and it is also odd. This is because negative f of x is equal to f of negative x. To put in an example, let's look at the point 1, 1. Negative f of 1 should be equal to f of negative 1. And plugging this into our original equation, you can see that negative 1 is equal to negative 1, proving it is odd. The end behavior is as at the limit as x approaches in positive infinity, it is positive infinity. As x approaches negative infinity, it is negative infinity. That is the identity function. The next function we'll be looking at is a squaring function. The equation for this is f of x is equal to x squared. the graph would look like this. The domain is from negative infinity to positive infinity. The range, however, can never be 0, so it is from 0 to positive infinity. This is because any real number squared cannot be less than 0. It is increasing on the interval from 0 to infinity. It is decreasing on the interval from negative infinity to 0. It has an absolute minimum at the point 0, 0. And it is continuous and is also even. This is because f of x is equal to f of negative x. Let's plug in an example. Going on this equation, you can see that there's a point on the graph 2, 4. Based on this, the point of f of 2 should be equal to f of negative 2. And when you go into the original equation, you can see that 4 does in fact equal to 4, showing that this function is even. The function is bounded below, even though there is no asymptote. The end behavior is as the limit as x approaches infinity. We already showed was that it is approaching infinity. The limit as x approaches negative infinity, it is also approaching positive infinity. That is the squaring function. The next function we'll be looking at is the cubing function. The equation for this function is f of x is equal to x cubed. It looks like this. The domain is all real numbers. The range, unlike the squaring function, is also all real numbers. The y-intercept of this equation is 0, 0. It is always increasing, so it is increasing from the interval of negative infinity to infinity. Thus, it is never decreasing. There is no relative maximum, and it is continuous. The function is odd. This is because, as we showed before, negative f of x should be equal to f of negative x. Let's plug in an example for this one. Based on this function, you can tell there's a point on this graph which is 2, 8. Negative f of 2 should be equal to f of negative 2. Going back to the original equation, negative 8 is equal to negative 8, showing that this function is odd. It is not bounded, and the end behavior is that as x approaches positive infinity, the function also approaches positive infinity, and as x approaches negative infinity, the function approaches negative infinity. That is the cubing function. The square root function. It is represented by the equation f of x is equal to the square root of x. The graph of this function would look like this. Note it only exists in one quadrant. So, the domain would be from 0 to infinity. The range would also be from 0 to infinity. This is because the square root of number can never be negative unless it is imaginary. The y-intercept of this function is 0, 0, and it is increasing on its interval of 0 to infinity. The relative maximum and minimum is that it has an absolute minimum at 0, 0. It is continuous, and it is neither odd nor even. The function is bounded below because, like I said before, it can never be negative. The end behavior of this function is that as x approaches infinity, y also approaches infinity, even though it is increasing at a very slow rate. The limit as x approaches negative infinity does not exist. That is the square root function. The next function we'll be looking at is the natural logarithm function. The equation for this function is f of x is equal to the ln of x. This can also be represented as equal to the log base e of x. The graph of this function would look like this. The domain is from 0 to infinity. The range is from negative infinity to infinity. There is no y-intercept. However, this graph crosses the x-axis at the point 0, 1. The function is always increasing on its interval 0 to infinity, thus it is never decreasing. There is no max or min, and it is continuous. It is neither odd nor even. There is a vertical asymptote, however, at x is equal to 0. It is not bounded, but their end behavior is, as x approaches positive infinity, so does f of x. As x approaches negative infinity, the limit does not exist. That is the natural logarithm function. The next function we'll be looking at is the reciprocal function. The equation is this, and its graph is the domain is from negative infinity to 0 and 0 to negative infinity. This is because there's a vertical asymptote at x is equal to 0. The range is from negative infinity to 0 and 0 to negative infinity. This is also because there is a horizontal asymptote at y equals 0. There is no y-intercept nor x-intercept, and it is decreasing on the interval from negative infinity to 0 and 0 to infinity. Therefore, it is never increasing. It has no relative maximum, and it is not continuous. This is because it has an infinite discontinuity. The function is odd, and it is not bounded. The end behavior is that as x approaches positive infinity, the limit of f of x is equal to 0. As x approaches negative infinity, the limit of f of x also is equal to 0. That is the reciprocal function. The exponential function. The equation for this function is f of x is equal to e raised to the power of x. The equation looks like this. The domain is all real numbers, so from negative infinity to infinity. The range is from 0 to infinity. It has a y-intercept at the point 0, 1, and it has no x-intercept. It is always increasing on its interval negative infinity to infinity. Thus it is never decreasing, and it has no relative max or min. It is continuous, and it is neither even nor odd. It has a horizontal asymptote at the line y equals 0. The function is bounded below, and its end behavior is that as x approaches positive infinity, the limit of f of x is also approaching positive infinity, and as x approaches negative infinity, the limit of f of x is equal to 0. That is the exponential function. The sine function. Represented by the equation f of x is equal to sine x. The graph looks like this. This is where the domain is from negative infinity to infinity. The range is from negative 1 to 1. It has a y-intercept at the point 0, 0, also known as the origin. It is increasing on the interval from negative pi, 2 to pi, 2. Note that this cycle is repeating every 2 pi. It is decreasing on the interval of pi, 2 to 3 pi, 2. Note that it is decreasing on the interval pi over 2 to 3 pi over 2. It is also repeating every 2 pi cycles. It has a relative minimum at the point x over 2, but it is repeating, so every maximum can be found by x is equal to pi over 2 plus 2 pi n, where n is an integer. It has a minimum at 3 pi over 2, but that's also repeating, so the minimums can be found by x is equal to 3 pi over 2 plus 2 pi n. N is also an integer. It is continuous, and it is also odd. It is periodic, and it is bounded above and below. The end behavior oscillates between negative 1 and 1. That is the sine function. The cosine function. F of x is equal to cos x. The graph is somewhat similar to the sine function. The domain is all real numbers, so it is from negative infinity to infinity. The range is also from negative 1 to 1. There is a y-intercept at the point 0, 1. and it is increasing on the interval of pi plus 2 pi n. And also 2 pi plus 2 pi n. It is decreasing on the interval of 2 pi n and pi plus 2 pi n. The absolute maximum is 2 pi n. Absolute minimums are at pi plus 2 pi n. It is continuous and it is even. Like the sine function, it is also periodic and it is bounded above and below. The end behavior oscillates between -1 and 1. The next function is the absolute value function. F of x is equal to the absolute value of x, which is represented by this. The graph is the domain is all real numbers, so from -infinity to infinity. The range is from 0 to infinity. It has a y-intercept at the point 0, 0, and is increasing on the interval of 0 to infinity. It is decreasing on the interval from -infinity to 0. It has an absolute minimum on the point 0, 0. It is continuous and it is even. It is bounded below as an end behavior of when x is approaching positive infinity, the limit of f of x is equal to positive infinity. And as x approaches -infinity, the limit of x is also approaching positive infinity. That is the absolute value function. The next function is the greatest integer function. The equation is f of x is equal to the greatest integer of x, also known as the integer x. The graph looks like this. The domain is all real numbers. The range is every integer. This is because the values here is 1, 2, 3, etc. -1, -2, etc. There's a y-intercept at the point 0, 0. It is always increasing on its interval -infinity to infinity, and it is never decreasing. Note that this function is constant on the interval of n to n plus 1. It has no relative maximum and it's not continuous. It has a jump discontinuity. It is not bounded, and the end behavior is that as x approaches positive infinity, the limit of f of x is equal to positive infinity, and as x approaches negative infinity, the limit of f of x is equal to negative infinity. That is the greatest integer function. The final function is the logistic function. equation is f of x is equal to 1 over 1 plus e to the negative x. The graph is the domain is all real numbers, and its range is 0 to 1. The y-intercept is 0, 1/2. And it is increasing on its interval negative infinity to infinity, and it is never decreasing. It has no relative maximum, and it is continuous. It is neither odd nor even, and it has two horizontal asymptotes. On the lines y equals 0 and y is equal to 1. It is bounded above and below, and its end behavior is as x approaches positive infinity, the limit of f of x is equal to 1, and as x approaches negative infinity, the limit of f of x is equal to 0. So these are the 12 basic functions, and hopefully after watching this you can now identify each function by its graph and know their key terms. Thank you.